Alright, this is Mr. Gillum, and today we're going to be evaluating expressions with exponents. This is on page 150 of your instruction book. I know this one's already worked out in your book, but I want to make sure that it's clear about how this works. You can see it says write and evaluate an expression using exponents to find the total volume of the 4 cubes shown below. So when we talk about volume, we're talking about cubic units, okay? Volume is cubic units. Okay, that means we put a 3 above the units to indicate that we're talking about volume. Okay, that's called, we're cubing the unit. So we call it cubic units. So our answer should be, in this case, cubic centimeters, because we're trying to figure out how much space is inside of each cube. Now, as I'm analyzing this, and before I start solving this, what I do see is that each of these cubes is exactly the same. They have a height, a base, and a length of 5, 5, and 5. Okay, so in order to calculate how much space is inside of a cube, what we do is we multiply the height times the base, where we find the area of one side, and we multiply the length of the prism. So in this case, we would multiply 5 by 5 by 5 to find the volume. So in that case, we could consider each of these as 5 times 5 times 5, and then this one could be 5 times 5 times 5, and that would be the volume of this one as well as this one. But we need to be careful because it looks like to me we have 12 5s up there, but each of those volumes is separate from the next. So this volume for this cube plus this volume for this cube plus this volume plus this volume is actually the total volume that I have. So it's really, I'm adding the sum of these 5 times 5 times 5s. Okay, so it says write and evaluate an expression using exponents to find the total volume. So this would be an expression if I had 5 times 5 times 5 plus 5 times 5 times 5 plus 5 times 5 times 5 plus 5 times, but it says to also use exponents. So instead of writing 5 times 5 times 5, what I could write is 5 third to the third power cubic units, okay, plus 5 to the third, otherwise known as 5 cubed, plus 5 cubed, plus 5 cubed. So that would be my expression, 5 to the third plus 5 to the third plus 5 to the third plus 5 to the third. Okay, so it looks like the book actually said, okay, well, if I have 5 to the third 4 times, I could also write that as 4 times 5 to the third, which would be the same as adding 5 to the third up 4 times. So I guess either one of those expressions would be appropriate. And when we calculate that, if I calculated that, and it does say find the total volume, I know that 4 times 5 cubed, we do parentheses, otherwise known as grouping symbols. Don't see any of those. I see exponents, so this will be the next step that I need to take. Everything else stays the same. I'm thinking of this as 5 times 5 times 5. That's what I'm thinking of that as. And I know that 5 times 5 is 25. And I know that 25 times 5 is 125. So really I'm thinking, what is 4 times 125? And I know that equals 500. And I need to label my units correctly because we're talking about centimeters. You can see that little 3 above the centimeters. It looks like centimeters cubed, but really we would pronounce that cubic centimeters. Okay? It says, in an old story, a man puts 2 grains of rice on the first space of a chessboard. He puts 4 grains on the second space, 8 grains on the third space, and so on. Write and evaluate an expression with the exponents to find how many grains of rice the man puts on the 10th space. Okay, so one thing that I could help to visualize this with would be a table. So if I made a table here, and I said this is the square number, and I said this is the number of grains of rice. Let's try to find a pattern here. On square number 1, he had 2. On square number 2, he had 4. 3, he had 8. And so on and so on. So we could figure out on the 10th square if we continued our chart, but really, blah, 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 we just need to skip right to 10. So how could I figure that out? Well, it's important to find a relationship between these two things. So I notice when I do this that these could be considered exponents. Okay, this number represents 2 to the first power, and this number represents 2 to the second power squared, and this number represents 2 to the third power cubed. So I could work on this and say 16 and see if this pattern continues, but I'm going to notice really quickly that 2 to the fourth is 16. And so it says write an evaluating expression with the exponents to find how many grains of rice the man puts on the 10th space. So you can see that I'm kind of following a pattern, 2 to the first, 2 to the second, 2 to the third. I'm just following the number of squares that have gone by, and that actually represents the exponent on my 2. So in this case, I would think that an expression that would represent the number of grains of rice could be written as 2 to the 10th power. So let's take a look at what the book says. Okay, yeah, 2 to the 10th power. And then they actually find, it says to write and evaluate. So we do need to actually figure out what 2 to the 10th power is. So what I'm thinking, and it's kind of a longhand way, but I want you to understand how this works. Better yet, let's use some knowledge that we have already figured out. So I know that I could figure out 2 to the 10th power would be like, do you see how I already know that 2 to the fourth is 16 and 2 to the second is 4? So we kind of did some charts like this where we could figure out additional things later on in the chart. So if I think about this as 2 times 2 all the way through 10 2's in a row, 2, 3, 4, 5, 6, 7, 8, 9, 10. I can think of these first 4 as 2 to the fourth, and I already know what number 2 to the fourth represents. I can think of these second 2 numbers as 2 to the fourth. I already know what 2 to the fourth is represented by or is evaluated to. I can think of this as 2 squared. So really, without having to think about, okay, or losing track of how many 2's you have, if I already know that I have 2 to the fourth times 2 to the fourth times 2 squared, then I really just have 16, which is what we already know, times 16 times 4. So it might be a little bit faster way for you to calculate these things if you group the 2's into parts that you already know you already know the value of. So 16 times 16, ooh, that's a perfect square number. We should know that is 256 because I know we memorize our perfect square numbers times 4. And so you may not know 256 times 4, so that might take a little work. But I have a feeling it's going to be 1024. Bada bing! 1024 grains of rice on the 10th square. He's going to run out of room on his 11th square, I believe. He's going to have to fit 2048 grains of rice on the same square. It's going to be hard for him to do. So let's take a look at the next problem. It says, Moira does 1/2 of a homework assignment on Monday. On Tuesday, Wednesday, and Thursday, she does 1/2 of the homework she has left over the day before. Write and evaluate an expression using exponents to find the fraction of the original assignment Moira will have to do on Friday in order to completely finish her homework. Ooh, it's a tricky question. It's a tough one. Okay, so it says here that she starts and she does 1/2 of her homework assignment. Okay, so half of it is done, half of it is not done. Okay, that's on Monday. On Tuesday, it says Wednesday and Thursday she does 1/2 of the homework she has left over from the day before. So she has, if she's done 1/2 of it, she does half of what's left. So she's doing half of what is left. So that tells me I need to, with this word here, this of, half of something is when I'm multiplying. So I know that this Tuesday would be 1/2 of 1/2. Okay. Now Wednesday, this much is left. 1/2 times 1/2, and then I want to do half of that. And then Thursday, I have all of these 1/2s, and I want to do half of that. And so Friday, it says find the fraction of the original assignment Moira will have to do on Friday in order to completely finish her homework. So we need to figure out what we need to figure out what Thursday is to know how much she has to do Friday, because she has to complete everything. So let's take a look at this. You can see that writing 1/2 gets kind of tedious and kind of irritating and annoying. So really what I want to think about these as different exponents. So when we have a fraction, we always put it in parentheses with its exponent. So that's 1/2 to the first. We would represent this as 1/2 to the second, or 1/2 squared. This would represent 1/2 to the third, or 1/2 cubed, and this would represent 1/2 to the fourth power. Okay, that represents how much homework that she has left to do. So let's make sure. It says, how much will she have to do on Friday? So although it says on Friday, how much does she have to do? That means we need to know how much is left after she's done half of her work on Thursday. So when we use exponents for fractions, it is again the same idea. We multiply the fraction out. And so when we multiply, we can multiply straight across. 1 times 1 times 1 times 1 is 1. 2 times 2 is 4, times 2 is 8, times 2 is 16. So on Thursday, she will have 1/16 left of her homework to do, and so she needs to finish all of that on Friday. That's how much she'll have to do on Friday. She won't do half of the 1/16. She will do the entire. She has to finish the whole thing on Friday. So that was kind of a tricky question. But again, I want you to incorporate exponents even with fractions. So yeah. It says to evaluate this expression, and this is a beast of an expression. So this is actually an order of operations question. And so if you're thinking PEMDAS or whatever you're thinking, that's fine. But we're going to start with any grouping symbols that we see. So I'm going to rewrite the problem over here so I have plenty of room to work. 6 plus 2 cubed minus 12 all over 5. I should have said this. Quantity 6 plus 2 cubed minus 12 all divided by 5. That would have been a more appropriate way to say that. Anyway, we're going to go ahead and start. And if you want to think about PEMDAS, that's fine. But just make sure that you do these 1, 2, 3, and 4, those steps in that order. So I'm looking for any parentheses, but really any grouping symbols. And I do see some grouping symbols. I'm going to highlight those in green here. So anything inside those grouping symbols needs to be calculated before I change anything else in this expression. So I know that 6 plus 2 is 8, so I'm going to go ahead and change that 8, and I'm going to leave everything else exactly the same. I'm not going to change anything for this step. Okay. Now that I have done the operation inside the grouping symbols, I can consider whether I need the grouping symbols or not. Because there are no more operations inside the grouping symbols, I can now remove the grouping symbols and continue to simplify my problem. So again, what I did was I just did what's inside the grouping symbols. I didn't change anything else. I'm looking inside here still, and I don't see any operations, so the parentheses are no longer needed. They're no longer necessary because there are no more operations, no add, subtract, multiply, or divides inside those parentheses. That seems like a tedious step, but it's important to know when to get rid of the parentheses for later on when we learn about that. Okay, so we've done everything with grouping symbols. Now we're looking for exponents, and I see that the exponents are here. Okay, so that's the part I'm going to change next, and I'm going to think about 8 cubed as 8 times 8 times 8 minus 12 all over 5. So I can do a little scratch work on the side here. I know 8 times 8 is 64. 64 times 8 looks like 512. So really, when I'm simplifying my exponent here, I have 512. That's how much 8 to the third power is. It is not 24. A lot of times students want to think, just keep the number small, let's just make it 24. That seems easy. That's not really how it works. So don't do that. So now we have 512 minus 12 all divided by 5. Now, we can think of this several ways. Because the entire thing is being divided by 5, we actually need to simplify the numerator before we start messing with the denominator. So that's kind of a caveat to the order of operations rules, because I know that usually I would say, oh, the fraction bars, it means division. Yes, that's true. But because it's dividing everything on top, if we wanted to write this differently, we would have to write, we would not be able to write 512 minus 12 divided by 5. That is not really what it is. If I separated it and changed it to a division sign, because everything's being divided, this would actually have to be in parentheses. That's why we're going to just do the numerator right now, and then we're going to mess with the denominator. So if you wanted to separate that into a division, you would have to keep everything on top in parentheses, and that's why we're still working on the top. On the top, 512 minus 12 would be 500 divided by 5. 500 divided by 5 is 100. Jerry chose A. He made a bad choice because he did not follow order of operations.